Here we have a problem that says graph the linear inequality y is less than negative 4x plus 5. Alright, when we're graphing inequalities, we have to take a slightly different approach than when we're just graphing an equation. First things first, that you have to make sure of every single time, you have to make sure that it is in mx plus b form, as if you were graphing an equation, basically. So our problem here is in some number times x plus some number, so mx plus b. It's already in that proper form. If it's not, then you've got to manipulate things around in order to get it into that form first. So what we're going to do now, since we have that in the proper form, the 5 here will be our y-intercept, and this negative 4 is our slope. So we can go ahead and we can plot these as if we were going to just graph an equation like normal. Alright, so our y-intercept they said was 5, so I'm going to go ahead and plot that point right there. And then they said that our slope was a negative 4. So remember, if you need to see a rise and a run, you can always put that over 1. So that says to get to the next point, we go 1, 2, 3, 4 down and 1 over. Now, so far we've been doing this exactly as we would if we were doing just a regular graphing an equation. But here's where it starts deviating or changing. We have to look at our symbol. Do you remember that whenever we were working with graphing inequalities, just things like, x is greater than 3 or x is greater than or equal to 3, there was a big difference between those two. In one of them we used a parenthesis and the other one we used a bracket. When we're graphing inequalities on x and y axis systems, we have a very similar problem. If you just have an inequality, then our line is dashed or dotted. If we have equality as part of that symbol, then our line is solid. The reason for that is because, like in this problem, we have just less than. So that means that my line here is going to be dotted, and trying to do a semi-straight, oh, that is just pitiful. Semi-straight line here. Not very straight, but we'll get the idea. Because every point along this, if it had been a solid line, then every point along here would work in the equation. But because this is just less than and not any equal to, then any point along this line acts more like a barrier rather than an exact solution. So we're going to go ahead and start graphing it, just kind of to recap. Start graphing it as if it were an equation using your y-intercept and your slope. But then your next step is you have to decide whether your line is going to be dotted or if it's going to be a solid line. So now for the next step, because inequalities have many solutions, a whole lot more than just a regular equation, one side of this line, every single point will work in the equation, and on the other side it will not. So we need to decide which side works and which side doesn't. What I like to do is to take a test point, and 0, 0 is always the best one as long as it's clearly on one side or the other of your line. In this case, 0, 0 is clearly on this side of our graph. So I'm going to use a test point of 0, 0. And what I'm going to do is I'm going to plug that into the equation and see if it works. So 0 less than negative 4 times 0 plus 5. So we have now 0 is less than 5. Is that a true statement? Well, yes, it is. So 0, 0 is part of the solution, which means everything on this side will also be part of the solution. Now, be careful for what you're doing, because if you need a solid line, you'll have to choose this option on my math lab. If you need a dotted line, you'll have to choose this option. And then to shade, you grab this little paint bucket here and click on the side that you want shaded, and it will shade it for you.